Hello, everybody, and welcome to lesson 5.6 in your textbook on page 329. By the way, I believe this is the last lesson in chapter 5. There's going to be a small exercise at the end with radicals, but I'm going to give you an IXL assignment on that. And then after chapter 5 is completed, we're going to have a test on it this week, Thursday or Friday, so make sure you know about that. And this week, meaning today is the 5th, October the 5th, so Thursday or Friday. So geometric sequences. So we talked about arithmetic sequences before, and it's a string of numbers that in an arithmetic sequence have a common difference, which is you add or subtract the same number to get to the next number. Common difference was the word. Now today we're talking about a geometric sequence, which is another string of numbers or objects, but it's not adding or subtracting, it's multiplying and dividing that we're going to look. And that's called a, so let's say I'm going to just a collection of numbers or string of numbers. I don't know how to else word it. Sometimes it's objects, but mostly it's numbers. And that have a, it's called a common ratio. This was review, by the way. Common ratio. And the word ratio implies division. A ratio is like a fraction. So that means division. Yeah, so if you go backwards, it's division. If you go forward, it's multiplying. But we're going to call it division because it's called a common ratio. By the way, in our formula, it'll be the letter R, lowercase r. Okay, common ratio. So we're going to learn how to write formulas, but I'm not too keen on recursive. I want to more do explicit formulas for geometric sequences, okay? And in our essential understanding, in a geometric sequence, the ratio, a fraction, A over B, a ratio is a division problem of any term. By the way, the numbers are called terms, to its preceding term. So it's always the previous one is a constant value. So the common ratio is always the same number. That's what this means, okay? So let's write the word fraction. Ratio is a fraction, it means division. So in your calculator, you wanna look for your division key, okay? And what this means, the preceding term, it means that you always divide the second number by the first number. And the third number, you divide by the second number. You always go backwards. And I'm just gonna write divide backwards and I'll show you. Yeah. Preceding. Now, all this right here looks pretty hard to understand. What I really want is pay attention to the explicit formula. Explicit formula tells you how to find any term. Oh, here, let's read that. A geometric sequence with a starting value, you always want the first number, which is a sub 1. It's just called a sub 1. First number. You always want the starting value, first number, and you always need the common ratio. Remember, common ratio is that division and it's denoted lowercase r, yeah? And then it tells you all this here, how to use it. But the one I really want to look at is this one down here. I'm going to rewrite it. I'll rewrite it here. So you have it. Explicit formula helps you find any term in the sequence. You don't have to write them all out. You use the explicit formula and you can find the hundredth number in the sequence, or the thousandths, or the 50th, whatever you want, okay? The explicit formula just means you take the first number and you multiply it by the common ratio to the power of n minus 1. So you take the first number in your sequence, you need the common ratio, and the letter n means which term are you looking for? What number? Which, is it the 50th, the 51st? Which term do you need to find? And then a sub n means answer. This is just the answer. So these are those symbols, yeah? Now remember, you do not multiply the first number times the common ratio. You always evaluate the power first. And whenever you get that answer, you multiply that by the first number. That's called order of operation. I don't mean to destroy that. I'm going to fix it so you can still copy it. There. Okay. So this should be enough information. The recursive formula helps you find the next term. All that means is that you take the previous term, if you're really interested in this a sub n minus 1 means the previous term, and you multiply it by the common ratio to get the next term. So the recursive formula helps you find the next term, and the explicit formula helps you find any term in the sequence. So let's look at some examples. We're on page 330, problem 1. Oh, look at the top. Every geometric sequence. By the way, not every sequence is geometric. You have to test it. A lot of the question will tell you it's geometric, and then you can count on it. But if it doesn't say it's geometric, you got to test the numbers to make sure they have that common ratio. If not, then you can't do whatever it is we're doing. Then it's just a sequence of number without any connection. Every geometric sequence has a starting value, which is that first number, a sub 1, and a common ratio, which is that lowercase r. The starting value and common ratio define a unique geometric sequence, meaning you're going to get a unique or a special string of numbers using the first number and this common ratio. Identifying, so we're going to test it. Which of the following are geometric? We don't know for sure if they are. Yeah. If it's not geometric, is it arithmetic? So two-part question. So let's look at this. So remember, first term, second term, third term, fourth term, fifth term, dot, dot, dot. It continues. When we test, we take the second and divide by the first. Then we take the third and divide by the second. Then the fourth, this is what I'm talking about backward, divided by 12. And then the fifth, and divide by the previous one, 24. And then let's see if those are all the same. That defines a geometric sequence, if those answers are the same. 6 divided by 3, use your calculator. 6 divided by 3 equals 2. 12 divided by 6, same thing. 24 divided by 12, use your calculator and check it out. 48 divided by 24. This is geometric sequence because the common ratio is the same. And the word in math is constant. If it's the same, it means constant. Let's look at this one. 3 to 6 to 9 to 12 to 15. I can tell it's not multiply, that it's not a division. If I divide 3 by 6, No, 6 divided by 3 is 2, but if I start 9 divided by 6 is not 2. Neither is 12 divided by 9. So you notice common difference, 6 minus 3 backwards, 9 minus 6 backwards, 12 minus 9, 15 minus 12. And you notice the common difference is always 3. So it's arithmetic. Common difference is constant. By the way, these three mean so therefore, so in math we don't need to write everything, therefore it's arithmetic sequence. And sometimes you don't find any connection, then it's not neither, you don't have any. Those are the only two that I know of. Well, there's a couple others. There's the Fibonacci numbers. There are other sequences. That's true, I shouldn't say that. It's arithmetic, it's geometric, and you can test, but not all of them have a connection. This one here is not, because from 16 to 22, this is neither. And I thought for the heck of it, I'm going to show you this one because it's got the fractions. And you go like, oh, what do I do? Not that hard. 1/9 divided by 1/3. I'm going to show you how to divide two fractions. Remember the saying, dividing fractions, it's no lie, flip the second and multiply. So a dividing fraction, it's no lie, flip the second fraction and multiply. And when you do that, this part goes away. So 1 times 3 is 3, 9 times 1 is 9. So 3/9 is 1/3. By the way, all of these will be 1/3. I already checked them. I'm not going to go through it. It's the same with the second and the third. Your common ratio is 1/3. I'm going to invite you to check them all, just to make sure I'm doing this right. Right? And this one doesn't have any because this is 3, this is 4, this is 5, this is 6. So yeah, no, that doesn't work. And then I wanted to show you on the bottom, notice how they toggle back and forth between positive and negative. Again, let's read what we're supposed to do, determine whether it's geometric sequence. So we always want to check to find a common ratio to see if it's geometric. But when they toggle back and forth between positive and negative, our common ratio is negative always. So start with the second, divide by the first. Take the third, divide by the second. Take the fourth, divide by the third. So that's -2, -2, -2. Common ratio is -2. Yes, it's geometric. So by now you should be familiar with how to check to make sure a sequence of number is geometric or not. Yeah, you find the common ratio, make sure the order is backwards. Okay, so that was the first part. Next, we're going to write an explicit formula. So we're on page 331. Any geometric sequence can be written only if it's geometric, by the way. If there's no connection with the numbers, then you can't do any of this stuff. But if it is geometric, you can write it as an explicit or also recursive formula. The recursive formula is useful for finding the next term. I'm not paying a whole lot of attention to that. I'll show you one example in the sequence. The explicit formula is more convenient when finding the nth term, which is any term. Okay, find the recursive and explicit formula for the following. It is geometric. The common ratio is 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. We need the first number, a sub 1, and we need the common ratio. Those are they just happen to be the same number. Kind of dumb, but oh well. So let's do explicit first. So with the explicit, you take the first number, then comes a parentheses, then comes the common ratio. You can write n minus 1 inside the parentheses, or I showed you like this earlier. Oh, by the way, this is r is 2 also. Or you can write 2 times 2, close the parentheses. I like this one actually better. I'm just going to start doing that instead of this, but they are the same. Okay, so this is the explicit formula. First number times common ratio to the power of, it's always n minus 1. You always take away 1 when you want to find, let's say you want to find the 90th number, you take 90 minus 1, you raise it to the power of 89. Okay. The recursive is you take the previous term, which is denoted a sub n minus 1, and you multiply by r. And so that would be, well, it's the same thing, 2 times 2, that's it. That's it in our case. 2 times 2 is 4. You always take the previous term and multiply by 2. Yeah, so here, let's just say this. It's just too weird. To me, it makes more sense to just look at it. How do you get the next number? You multiply by 2, right? I always like to follow the pattern. This makes students more confused. What is she talking about? Just find the next number using your common sense, looking at the pattern. So this is why I don't want to pay too much attention to recursive, but I want you to know about explicit. Okay, so here, let's look at B. We want to write the explicit 40, 20, 10. The common ratio, the first number is what we start out with, 40, but we also need that common ratio. 20 divided by 40 is 1/2. Okay, when the common ratio is less than 1, your numbers are going to get smaller. And I'm not checking all these because they already told me that here. They didn't say check. They told me write the formula. So I'm assuming these are geometric. So I don't need to check every one of them to make sure my common ratio is the same. Yeah. So the common ratio is 1/2. So the recursive formula is the answer is the first number times the common ratio raised to the power of n minus 1. There's the recursive, the explicit formula. Explicit. Oops. How did that happen? Oh, I moved that thing over. Okay, so where were we? Yep, there's your explicit formula. That's what that mistake was. I didn't want to use the wrong word, explicit formula. That's the one I'm paying more attention to. All righty, next page. Problem 3, I believe. We are up on top. And now we're going to use find the 8th term. Okay, so this one, we're not going to use the recursive, cross it out. We're going to write an explicit formula. So that's the first thing. And then second, we're going to find the 8th term. So there's 2 items. So I'm going to make us notes over here. First, you're going to find the first term. Tell me if you like me to make bullets. That helps my students a lot. 2, find common difference. Oh no, it's not the common difference, it's common ratio. 3, write explicit formula. 4, plug in for n 8 because we're looking for the 8th term. Yeah, and 5, evaluate. Evaluate means use your calculator and find the answer. So first term, a sub 1, 14. Common ratio, R, 84 divided by 14 is, use your calculator, it's 6. Write the explicit formula. So we have the first term times the common ratio to the power of n minus 1. If you want, you can put a sub n, which gives you the answer. You don't have to. Then we're going to plug in for n8. Now we evaluate. 8 minus 1 is 7. Find this number, 6 to the power of 7. Use your power key. And then when you get that answer, leave that number in, use ANS times 14 equals. So 14 times 6 to the power of 7 is, oh, I wrote the whole thing. I gave you the whole answer. It's going to be 3,919,000 and 104. Wow. Do you notice how exponential stuff goes big, quick? This is 1, 2, 3, 4 terms, 5th, 6th, 7th. The 8th number is already at almost 4 million, starting at 14. And the reason is the 6 is a big base and we're taking it to the power of 7. This is a big number. So again, put 6 to the power of 7 equals in your calculator. Do not retype the number. Just use that answer and times it by 14 and then equal again. This is the order of operation you need to observe every time. Yeah, make sure you do it. Use your calculator and this is our answer. All right. And down here, we're going to do the science problem. And I don't know what fluorine 18 is, but it's one of these science things. When a radioactive substance decays, that means it's getting less. So our graph would go down like that. Measurements of the amount remaining over constant intervals of time. So look at the time. 0, 1, 10, 220, the time gets added 110 minutes each time. But what we're really looking at are the numbers here. So check this out. This is our string of numbers. So you got 260 is our first number, 130, 65. You can tell they're going down by half. And then dot, 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 meaning it keeps going. So A1, A sub 1, A sub 2, A sub 3, A sub 4. I can tell that the common ratio is 130 divided by 260. Use your calculator. It's 0.5 or 1/2, either one you want to use. And here's our first number. I know we're going to have to write an explicit formula, so I'm already preparing myself and setting myself up. Remember up here, find the first term, find common ratio, write explicit formula. Same thing. Write the explicit, there you go. Write the explicit and recursive. No, we're just doing explicit. For the geometric sequence formed by the amount of FL-18 remaining. So we got the first term, we got the common ratio. So here's our explicit formula. 260 times, if you want, use 0.5 to the power of n minus 1, always to the power of n minus 1. That's it. That's all they want. They didn't make it hard. They didn't ask how much is remaining after such and such time. They only want the formula. So when you read the question, sometimes, you know, and now we're gonna, no, I'm gonna do this last problem down here, number 8. Write and graph the function that represents the sequence in the table. So we're going to write, you have two things, write and graph. So again, I'm looking at these numbers. So the x goes up at an even interval, but you just check on that, but that's not important. The numbers we're looking at is 8, 16, 32, and 64, and then we can keep going. So the formula wants the first number and the common ratio. 16 divided by 8 is 2. So the formula is 8 times, or without the times, 2 to the power of n minus 1. There's the function. Oh, they're using the word function. It's the same thing. Function formula. So there's that. This is part of the question, right? Function. Now we have to graph it. So when I graph it, I'll just plot these points. Make it easy. Notice they're all positive, and so I don't need the negative part. So I'm gonna do quadrant 1 mostly. So I go, here's my 0, 1 on the x. On the x, I only have to go to 4. So, oh yeah, if I go to 4, I don't need the small, I'm gonna go by 2s. 1, 2, 3, 4. On the y, I have to go to 64, so that makes it harder. I have to make, I'm gonna go by 10s. 10, 20, 30, 40, 50, 60, I'll go to 70. So 1 goes with 8, 2 and 16. I'm estimating where it is, 3 and 32, 4 and 64. And then it keeps going steep. It's gonna go steep. This is how the graph will look. It approaches the x-axis. It's an asymptote. I talked about that last lesson or previous. It'll never cross the x-axis, but I don't know how to explain it, but it will never cross the x-axis or touch it. It'll never be 0. And then it takes off. So it's a smooth curve. It's not a straight line. All right, next page is homework. Make sure you review your notes before you start on the homework. You want to match up the questions with your examples I gave you. Determine whether it is yes or no. Find the common ratio. Remember, divide second by first, third by second. It has to match. It has to be the same number, and then it's yes. Okay, so you're gonna try all these, and then you have to find that number. 9 divided, I already can tell, yes it is. Common ratio is 3, I can see it already. Try these two. And then here we're not writing recursive, we're writing explicit. 12, 13, 14, 15. I'm going to do 13 for you because we got that positive negative. Remember, for the positive, so the first term, this is the symbol for first term is 4. The common ratio is going to be negative because if it goes back and forth, it's going to be -2. -8 divided by 4 is -2. So the formula, explicit formula is 4 times, open parentheses, common ratio to the power of n-1. Always to the power of n-1. Okay, and then the same for these two, 14, 15. On this page, critical thinking. What are the similarities and differences between arithmetic and geometric? I talked about it in the beginning of the video. What's an arithmetic sequence? What's a geometric sequence? What's different? Maybe you can think of something that's similar too. Mostly they're both sequences. You can both find any number using a formula. And on the last page, we're on page 336, the science. So on this one, it's a little tricky again. Sometimes I like to give a little harder questions to make you think. A certain culture of yeast increases by 50. So it's going up half every 3 hours. So it's going up half. Increases half every 3 hours. He's starting out with 9. So think of writing the numbers. What would be the next one? So there's 9, whatever it is, yeast culture in this petri dish. What's going to be 3 hours later? How many are in there now? Think about it. It increases by half. What's half of 9? And then add it, right? So then you come up with the next term. You don't have to write recursive. And then try that again. What's the next one? How many are in the next one? Do a few, and then you need to write the explicit formulas. Yeah? It's not that hard. Good luck to you.